Let theta be a non-acute angle in standard position that is not a quadrant angle. The reference angle of theta is the positive acute angle theta prime formed by the terminal side of the angle and the x-axis. So let's take a look at an example here. Find the reference angle for an angle in standard position with a measure of 165 degrees. So we have this 165 degree angle whose terminal side is in the second quadrant. Let's make sure it fits the description. So theta is non-acute because it's greater than 90 degrees, and it's in standard position because the initial side corresponds with the positive x-axis, and it's not a quadrant angle because it's not a 90 degree angle, a 180 degree angle, a 270 degree angle, or a 360 degree angle. So it's not a quadrant angle. And therefore, the reference angle of theta is the positive acute angle theta prime formed by the terminal side of the angle, which is this directed line segment right here, and the x-axis. So if we need an acute angle, we obviously have to measure the reference angle from the negative side of the x-axis. So the reference angle would be this little angle right here, that acute angle. You'll notice that the angle theta is smaller than a straight angle being 180 degrees. Actually, the difference between the 180 degree straight angle and the given angle that represents our reference angle. So if we want to find out what this rotation is here going clockwise, we just have to take the 180 degree straight angle and subtract from it the given angle, 165 degrees. That little rotation there, that little clockwise rotation from the negative x-axis to the terminal side of the given angle is going to be 15 degrees. And therefore, the reference angle here is 15 degrees. So for any angle in the second quadrant, we can find the reference angle by simply taking the given angle and subtracting it away from 180 degrees or pi radians if it's in radians. So the reference angle for the angle 240 degrees. So the way we find the reference angle is going to be different because you'll notice this angle is actually larger than a straight angle or a 180 degree angle. And the reference angle being measured from the negative x-axis once again is in a counterclockwise direction towards the terminal side of the given angle. And you'll notice that is actually just the excess of the given angle above a 180 degree straight angle. So if I want to find this reference angle, all I have to do is subtract the straight angle, the 180 degree angle, from the given angle. So theta prime in this case is going to be the given angle 240 degrees minus the straight angle 180 degrees. And this is how we're going to find the reference angle for any angle in the third quadrant. So for an angle in the third quadrant, we're going to take the given angle and subtract away from it either 180 degrees if we're in degrees or pi radians if we're in radians. And 240 minus 180 gives me a reference angle of 60 degrees. So the reference angle here is 60 degrees. Let's do another example. So let's look at this angle. And this time it's given in radians. Theta here is 4 pi over 3 radians. And in the same way, because this is the excess above the straight angle, I'm going to take the given angle, and to find this little rotation here, this from the negative x-axis to the terminal side of the given angle, I'm going to take the given angle and subtract from it pi radians, which is equivalent to 180 degrees. So when I do that, that's 4 pi over 3 minus 3 pi over 3, and I get 1 pi over 3 as the reference angle here. So that's pi over 3. This is actually the same example we just did. 4 pi over 3 is the same or is equivalent to 240 degrees. All right, let's look at another example. So now we're in the fourth quadrant. So when we're in the fourth quadrant, it's a bit different because now to get an acute angle, if I'm measuring from the x-axis, I have to go from the positive x-axis. And that would be my reference angle. That's the positive angle that we're looking for. Okay, so you'll notice here that this is not close to that straight angle. This is actually close to a full rotation, or a 360-degree rotation. So in order to find this reference angle, what we're going to do is notice that the 315-degree angle is short of the full rotation or 360-degree angle, and the amount by which we're short is the reference angle. So in order to find this reference angle, I'm going to take the given angle and subtract it from 360 degrees, and that means that this reference angle is a 45-degree reference angle. That's true for angles in the fourth quadrant. If you want to find a reference angle for an angle in the fourth quadrant, you're going to take the given angle and you're going to subtract it from 360 degrees, or from 2 pi radians if you're in radian mode. Let's look at this angle here. And that's theta equals 7 pi over 4. And it's the same situation. We're in the fourth quadrant, and being in the fourth quadrant, the reference angle is measured from the positive x-axis. And that means that we just need to figure out how short we are from a full rotation, or 2 pi radians. So to find this reference angle, I simply take the given angle and subtract it from 2 pi radians. That's going to be 8 pi over 4 minus 7 pi over 4. So we get pi over 4 radians. So the reference angle here is pi over 4 radians. All right, now let's take a look at how this works with negative angles. We have this example. Let's look at a negative 200-degree angle. So we have a negative 200-degree angle, and we want to find the reference angle for this negative 200-degree angle. All right, well, you'll notice that we are just beyond a negative 180-degree angle. So what we're going to have to do here is we're going to have to subtract away that negative 180-degree angle from the negative 200-degree angle. But because the reference angle is always positive, we need to find the absolute value of that difference. This is the reference angle that we're looking for, and to find that, theta prime, we're just going to do the negative 200-degree angle, and we're going to subtract away from it the negative 180-degree angle. But because that would give us a negative number and the reference angle is positive, we're going to do it in absolute value. So we get here that that reference angle is a 20-degree angle. 20-degree angle. All right, now the last example here, let's take a look at a negative 290-degree angle. The negative 290-degree angle, and you'll notice here that in order to get an acute angle, we can't measure from the negative x-axis anymore. We're going to have to measure from the positive x-axis. And in this case, we are shy of that 360-degree angle. So what we're going to do is we're going to take our angle, the given angle, and we're going to subtract it from the negative 360-degree angle. So theta prime is going to be that negative 360-degree angle minus the given angle. But because that's going to give us a negative answer and the reference angle is always positive, we are going to have to take the absolute value. So in this case, theta prime is actually equal to 70 degrees. And that's how we find reference angles.